Okay, so we're going to be starting our new unit today, and it is going to be over electricity, circuits, and today we're going to be talking about electrostatics. So a few things to remember if you've taken chemistry before, or you've probably learned this before in a science class, is we're going to be looking at how charges attract and repel each other, and when that comes into play, we need to look at the atom. So in the atom, there's a positively charged nucleus because it has the protons and the neutrons. And then around the nucleus is the electrons, which are negatively charged. And we're going to look at how they affect each other. So when comparing protons and electrons, the amount of charge for a proton is equal to the amount of negative charge in the electron. So if you have the same number of protons as you do electrons, you'll have a neutral charge. So most atoms are going to be neutral because they'll have the same number of protons as they do electrons. But if you lose or gain electrons, your atom is going to become charged. So if you gain electrons, then you'll have more of a negative charge, becoming negatively positive. And if you lose electrons, that means you're going to have more protons, meaning you'd become positively charged. So if you look at this picture here, this one has more protons than electrons, so we know that would be positive charged. These are equal, so there is no charge. And this picture here has more electrons than protons, so that would be considered negatively charged. And we can look at how they affect each other. Like charges are going to repel, so a positive and a positive, or a negative and a negative. And opposite charges are going to attract, so a positive and negative will attract each other. The law of conservation of charge, we've talked a lot about law of conservation of anything. We've talked about law of conservation of energy, law of conservation of momentum, and now we can look at the charges. And this means that charges are not, so electrons are not created nor destroyed. They're just going to be transferred from one object to another. So as you can see, for example, of this picture, if you have a sweater and a balloon, and if you've done this before, if you rub that sweater and the balloon together, that balloon is actually going to stick to that sweater because that balloon is going to gain some of the sweater's electrons, and that means that the sweater becomes positively charged. And if this balloon gained electrons, it became negatively charged. And we just found out that opposite attracts. So a positive and a negative are going to attract each other. So that is why that occurs. And then, like we just said, like charges repel, and more force, and then no force, meaning it would be a neutral charge, no force would be occurred. So again, the law of conservation of charge, we're looking at electrons. They cannot be destroyed or created. They're just going to be transferred from one object to another. And electrostatics is electricity at rest, and this is when the electric charges are held in place. So you can see this in static electricity or lightning. That is electrostatics. There's three ways to transfer electrons from one object to another. There would be charging by friction, so rubbing two objects together, such as the balloon and the sweater. Charging by contact, so just touching an object can cause electrons to transfer. And then charging by induction, that is through the air, so there's no contact needed. You can think of this as if you walk by a door handle and you've been walking on carpet and that door handle shocks you. Even though you didn't touch that door handle, it transferred those electrons through induction. So we're going to be talking about Coulomb's law. It has to deal with the charges and the strength of the force. So the three things that we're going to be relating is the charge of an object, the distance between them, and then the force applied between them. So force is inversely proportional to the distance between the objects, meaning if you increase the distance between the objects, you're going to decrease the force. So if you increase that distance, so making them farther apart, that's going to make the force less. And you can kind of think about this like magnets. If you have magnets and you have them, if you move them farther apart from each other, that force is not going to be as strong. Same thing with this. If you increase the distance between the two charges, so if you had them at this distance and then you increase that distance, it's going to cause that force to become less. And as you increase the distance even more, it's going to cause that force to become even weaker. So they're inversely proportional. The more distance you have between the objects, the less force you're going to get. And force is directly proportional to the size of each charge. Meaning, if you increase the charge of the particle, that is going to also increase the force. So if we have one positive and one negative, that's going to be 1 unit of attraction. Let's say we double our negative, so that's going to cause the force to double as well. So you get 2 times the force. And here, if you double the positive and you triple the negative, it'll be 2 times 3, so you get 6 times the force. So, again, they're directly proportional, meaning if you increase the charge, you're going to also increase the force. And that is it. Now I'm going to have you complete the practice worksheet.